It is my pleasure to be with you this morning, to be sharing some of my 40-plus years in contact with greenhouses. I am Norm, the owner and creative force behind Multi-Shelter Solutions of Palmerston, Ontario. With the show of hands just to start, how many here have one or more greenhouses already? How many expect to be purchasing a greenhouse in the near future? Hopefully I can give you some information that will help. There isn't anybody here that's here by accident. If you can't hear me, then just wave and I will either talk a little louder or get this microphone turned up. So let's start with the definition of a greenhouse. A greenhouse is simply a covered frame that protects plants from the elements for the purpose of enhancing growth. Many farmers today are using a greenhouse type structure, which is simply the same building with a different type of cover to provide a very economical shelter. When I Googled greenhouse images, there were literally thousands that came up. I was intrigued, I was informed, there were new ideas, I was amused. There were lots of images there that wouldn't stand up for 5 minutes in our environment. How many of you have been frustrated by a salesman that wouldn't listen? Or a customer that wouldn't stop talking long enough to listen to an answer? So often the purchase experience can be so much more meaningful if it just feels like you're both sitting on the same side of the table. There are a lot of good choices out there that are bad choices for the next person with a different set of circumstances and goals. And educating ourselves on all of the options is more critical than ever before because our economic survival depends on it. Usually when I start a conversation with a prospective customer, I start with two questions. What are you trying to accomplish and what are you dealing with? Now my grower experience is from the 70s and 80s, so part of that is certainly what you would call outdated, but still it gives me a perspective that a lot of people can match, like, because I'm more than just a nuts, bolts, and tubing specialist. There are lots of choices when it comes to greenhouses. This morning we're going to cover purpose, size, shape, coverings, orientation, and location. I'm going to draw attention to many of the things that can and will impact these choices. I've tried to keep the presentation short enough so that there will be time for questions at the end. With the exception of purpose, all of the rest of the choices are equally as important and not in the order of importance. They all need to be covered thoroughly so that you get a complete picture. And please remember that many of the points that I am going to be covering are oversimplified just to illustrate a point or for the sake of time. There are lots of equally important things that need to be considered that I won't be covering this morning, well, just in passing. Things like heating, ventilation, irrigation, lighting, shading, and soil management. All things that need to be considered, but not in this presentation. So starting with the first question, what are you trying to accomplish? Sounds simple enough. Trying to grow an early crop of lettuce, trying to cut down on my heating component, or I want to produce 2 or 3 crops with that particular greenhouse. Each of you will have your own thing that you're trying to accomplish. When somebody is starting off, or even if they already have one, I encourage them to start the proverbial wish list. The term implies that you're not going to get everything that you're after, but you need to have these things listed. You've all heard the adage, everyone can be profitable on paper, and this is certainly true. But it's a whole lot cheaper to go back to the drawing board than before you have posts in the ground. If your plans are for 5 acres of production tomatoes in the next 5 years, and you've got the resources for it, obviously your goals and all of your plans are going to be considerably different than if you simply want to generate some cash for a vacation. So you make your wish list, and you prioritize the wish list. Then you set out to start researching all of the different options. It's critical to ask questions. Ask as many questions as you can. You're going to reprioritize and reprioritize and reprioritize until you get it right. And above all, give yourself time. I'm sure you've all heard the line, if I wanted it tomorrow, I would have ordered it tomorrow. Well, maybe the salesman can make it happen, but it is going to happen at a cost. And be flexible. Life isn't going to go the way you had planned it, so unless you're flexible with those plans, you're going to have some very expensive correcting to do. Make sure that you add only a small dose of optimism to your plans. So the other part, what are you dealing with? The list includes all of the challenges that are going to prevent you from accomplishing your goal. It's a lot more harsh in Thunder Bay than it is in Leamington. There's a lot more snow in Barrie than there is in Dundas. It's a lot windier in Shelburne than it is in Caledon, even though they're neighbors. There's a lot less rocks and hills in Dresden than there is in Kingston. Cut roses require a lot more light than if you're growing vegetables. Or maybe you have a rookie banker that's going to make sure that there's no losses on his watch, and you're stuck with a very small budget. The list goes on and on. And I'm sure you've heard the phrase, there's 2 ways of looking at every situation. Well, I'm sorry, for this scenario, there's a lot more than 2 different ways to look at it. What are my choices for shape? Top left, Quonset, and you've got Gothic, you got A-frame, and you have flat. Quonset is the simplest and the cheapest shape. It's usually similar to a half circle. The width is usually quite narrow, and the buildings are relatively low unless you mount them on something. There's quite a bit of flexibility for building them on uneven ground, but the Quonset is extremely poor for shedding snow. A recent exception to the Quonset being the simplest and the cheapest is the coverall type of building. Because they're going so wide, they have to go extremely heavy with their trusses. They've gotten to be very expensive. They're also not used as greenhouses. The Gothic is more of a rounded profile going up to a peak. It is a little bit more elaborate in that it has a ridge going down the center. This gives you more options for width and height. It definitely is a better shape for shedding snow. This is the predominant shape that we do at multi-shelters. The A-frame has vertical walls, and then it goes up to a peak at 35 to 40 degrees. It is a more elaborate design because of how heavy the structure needs to be with the rigidity and the weight of the cover. So you're usually limited to pre-engineered sizes. The Space Saver is a combination of the Gothic and the A-frame in that it goes straight up, it has a tight curve, and then up to a peak. It is a shape that I generally suggest people stay away from because getting that tight curve does significantly stress the steel. The flat structures have limited uses because of the snow issues. They are fairly high cost. They're typically used for frost protection, daylight control, and for shading. Along with with the four shapes, you also have three configurations. You've got the standalone or ground-to-ground, you've got the gutter connect or multi-bay, and then you've got the retractable. The ground-to-ground is always done as a single building. Any of the shapes they're either literally mounted on the ground or they can be put on something to get a little extra elevation. The gutter connect have a common steel trough in between them. The biggest challenge for those is that the structure has to be strong enough to carry the snow load, or you have to have built-in snow melting capacity. The retractable units can either be flat or they can be the multi-bay. The term greenhouse is generally referred to something that is permanent and used year-round. It often includes a hard cover or double plastic and some sort of form of ventilation. The cold frame is semi-permanent and used as a season extender, and then the tunnels are portable and season extenders. It is an extremely important consideration as to how your structure will handle the weather. There are all sorts of different ways that you can beef that up, but obviously those changes will come at a cost. So it is critical that you have a good handle on what all of these upgrades are so that you can compare them as a cost versus benefit or a cost versus return. Everything that I will be, or that I have been saying, is sort of thrown out the window when you're talking about a retail greenhouse. Because the goal for a retail greenhouse is to get people in the door. Your ratio between available plant space and walkway is a lot poorer than a production structure, and the ends are a lot fancier because pretty counts for something. So now that we've covered some of the shapes and configurations, we will look at size. Your choices for width, height, length is a three-dimensional choice. Actually, you could probably consider the fourth being heavier or lighter. When you're picking a size of a structure, obviously your immediate need has to be taken into account. If you have a contractor produce 1,000 flats of petunias, like obviously you need 2,000 square feet plus a little bit of aisle space and maybe something for a heater. You also have to consider what fits on the property. If you only have room for 2 structures side by side and the first one takes up 3/4, you're going to have a problem for expansion. Also, it's a lot cheaper to go a little bit longer and fill up the lengthwise space now than to do that after the fact. When it comes to size, most of the time going narrower and longer is cheaper than going wider and shorter. The cost of the ends is the same whether you're building 30 feet long or 300 feet long. Now on the 2 boxes that I have on the screen, 30 by 30 and 20 by 40, both of them is 900 square feet. But when you consider the whole package of this, the covered area, which includes the roof and the ends, the one has about 2,100 square feet of surface area, the other one has 1,700, which is a difference of 25%, which means that the 30 by 30 is going to be about 25% more expensive to heat than the lower building. Going taller or lower does change many ways of how your structure will operate and react to the climate. Going taller is more expensive to heat because heat loss is in direct proportion to surface area exposed to the outside. The 20-foot wide regular, what we call regular, uses 32-foot wide plastic, and the taller one uses 36, which is a difference of 12.5%, means that you're spending 12.5% more to heat. And then you add that to the extra ends, it gets worse. On the positive side, the higher unit has more air volume, so the temperature fluctuates less, even though it does catch a little bit more wind. The higher units do shed snow much more efficiently than the lower units. Add to that the snow that is being shed on the higher units, the snow is piled vertically and is not nearly as much of an issue as on the lower units where the snow will be piling on an angle. So what changes more quickly? And I usually put this in a context that people can easily identify with when you take different sizes of bodies of water. A puddle is going to freeze much more quickly than a pond. A pond freezes more quickly than a lake. The same is true in reverse in the spring. The other thing is that a small body of water is much more likely to have algae on it, which indicates that you're getting less natural circulation. So a bigger volume gives you more natural circulation. It may be more expensive to heat, but a healthier environment for plants is going to get you a greater return. When you compare the profile of a greenhouse and an airplane wing, there are similarities. The problem is you want the opposite result. When you're sitting in an airplane, you want it to get off the ground. When you're standing in your greenhouse, you want it to stay. When you look at the wing of an airplane and you notice that on takeoff and landing, they will extend the flaps to give you more surface area, which gives you more lift. So when you're building a greenhouse taller, you're getting the same effect. You're getting more lift. The other problem, when you have more lift, you're also transferring your load to a different spot. Rather than the rib going right down to the ground, which is the strongest tension, you're now putting it on something which can be a flex point. When I send a drawing to the engineer for evaluation, it typically looks like this. This way, the engineer can plot all those different points into the computer and create points of evaluation. Because what happens is, the closer you are to the ground, the more wind load you have, but the less snow load you have. As you go up the curve, you have more snow load and less wind load. The structures are rated for three different areas. One being downforce, two being uplift, and three being lateral shift. Downforce is typically associated with snow load. Uplift and lateral shift are parts of the wind load. There's an interesting thing that happens when you're looking at these from an engineering perspective. It's sort of, and pardon the pun, a snowballing effect. You would think that going from 20 feet to 30 feet, which is a 50% increase, would mean that there's 50% more load. It's actually double. You combine that with the fact that a 30-foot structure is generally about 50% taller than a 20, you've also got a 100% increase in the wind load. So you combine the two, you can see why, as you're going wider, the structure quickly gets more complicated and heavier. So now going back to the comparison of the two 20-foot wide units that I had earlier, you've got a 12.5% increase in the surface area, which means you've also got a 25% increase in the uplift that you get on that structure. The same concept applies to the steel tubing. I have three different shapes of steel here. 1.5 inch round, 1 inch by 2 inch, and 1.5 inch square. These pieces of steel weigh equally, which means they cost the same. But anything that's got corners in it is probably 50% stronger than something that is round. Now, when you add to that, so now that eliminates the round steel. Now you've got 1 by 2 and you've got 1.5 square. This one is going to give you more lateral strength. This one is going to give you more vertical strength. So again, depending on what you need, if it's wind load, you need something that is wider or with more bracing. If you need something stronger, you go to deeper steel.
Norm, do you have set snow and wind loads that you use for design, or does it depend on the site?
It's going to depend on the site. So now we have the same thing when, like, rectangular tubing is what we make things out of because of the strength that you're getting. The 1 by 3 being 50% more sidewall strength isn't 50% stronger, it's actually more than double. So that brings to another point in that if you take the 1 by 2 on closer spacing, you're going to get a lot more shadowing than going with a bigger arch farther apart. The shadowing effect does decrease as you build the building higher. One thing that I've stressed over and over to customers is that you don't give Mother Nature even 1 inch of wiggle room. If we work at something for 10 minutes and it doesn't work, we give up and we move on to something else. Mother Nature doesn't have that restriction. If she has to wiggle at this for a year, so be it. If you give the wiggle room, your building will be destroyed. Also, if your building has survived a major storm, be careful in how you express your glee. Because if there has been any stress to this building, it's going to take half as much storm the next time, do twice as much damage. And the last point on this that I've stressed over and over again is there is simply no such thing as too many anchor posts. That brings us to covers. What I'll be covering this morning is glass, polycarbonate, plastic, and shade cloth. Glass lasts a long time. It has excellent light transmission, but it needs a much more elaborate support system. Glass is extremely poor at holding heat. It does break easily unless you do the added expense of tempered glass. Curved glass is a possibility now, but again, the structures are getting extremely elaborate. There's also polycarbonate, which is either a twin wall or a triple wall material. It is a hard plastic. It has very good light transmission, and because of the size of the sheets, there's a less elaborate support system that is necessary. It is excellent for heat retention, and because it is also, there's a whole range of buildings that this can be applied to. It is also a material that is used quite often as an end wall cover when there is that added value of, for a sales area where you need to have appeal. Polycarbonate on its own sells for between $2 and $4 a square foot.
Question? What determines the lifespan?
Oh, one thing thank you for the question. One thing about polycarbonate is that it does have an inside and an outside. The outside has got UV treatment to it. The inside has an anti-condensate. It is critical that you put this on the right way, because if you're putting it on upside down, the sheet will be gone in about 3 to 4 years. The intensity of the light in the area where you are will speed that up. Also, if you're near cities with a lot of pollution, this will speed up deterioration as well. If you are in a very dirty area, you can periodically with mild soap wash it to extend the life. And that brings us to polyethylene, or poly for short. The number one feature for poly is that it is very inexpensive. And it certainly has a good lifespan for the cost. The light transmission is relatively good, but it does deteriorate as it gets older. And structurally, plastic will last a lot longer than you quite often should have it on, simply because of the deterioration in light. It does require only a very simple support system, and the heat retention on plastic is very good when you consider the option of double plastic with air in between. You do reduce your heat loss between 20 and 40%, depending on the type of plastic and the consistency of the the air inflation. Plastic does damage fairly easy, but it is also easy to be repaired. A lot of beginners are extremely nervous about plastic, and whereas a person like myself that has been around plastic for 40 years, yes, I've seen the oopses occasionally, but when you consider how tough the plastic actually is, it does stand up very well. There are many, many choices for types of plastic and thicknesses, and it would take me way too long to cover all of them here. You are looking at between 8 and 17 cents per sheet of plastic.
On the previous, on the polycarbonate diagram, you had two pictures of plastics on the bottom. Can you explain what those were?
The one on the far side is a twin wall polycarbonate, which means it has 2 walls. The one in the middle has 3 layers, which means that it's a little bit more rigid and it has a little better of an R value. Now, once we get to questions at the end, I can flip back to slides and explain a little bit more in depth. Shade cloth is also an available covering choice. It is designed mainly just to reduce the intensity of sunlight. It does come in various percentages of shade. One thing to remember is that there seems to be a difference between what the stated number is and what the shade value is. Because if you take shade that is 50%, you'd think, oh, that blocks out 50% of the light. But it doesn't even come close to that. You can't leave shade cloth on in the wintertime because it doesn't shed snow at all. It definitely does add life to the cover under it, and it can also be used as a cover by itself. Orientation and location is not the same, but they quite often determine each other. If you're growing if you're growing a very light-sensitive crop, a north-south orientation is considered as the better way to go because it picks up sunlight better. A tree line is the only true windbreak because it lets the wind through more slowly. Putting a structure behind something else as supposed protection is a false sense of security because all that you're getting is swirling of the wind, and you're actually making it worse for your structure than if it was standing out in the open. If you orient your structure in line with the prevailing wind, if there is a snow load on the building, you're going to get a much more balanced snow load. It's also going to be a lot easier to ventilate. If you're building your structure 90 degrees to the wind, you will very likely have a situation where the snow is coming like this and falls on the back side. It is surprising how much snow these structures will handle if it's balanced. It's also surprising how little can cause a problem if it's all on one side. Another thing to keep in mind is that the wind patterns change totally when you're adding your second, third, fourth building. It's the same as if your first one you were putting it behind a barn to get some protection, or when you put up your second structure, you're in a way putting it behind the first one. The wind patterns change a lot. Exposure may be necessary for extra ventilation, but you have to consider that it will also increase your heating costs. When it comes to location, access and quality of water is critical. Never pick a site that isn't good for anything else. Potentially, like if you are putting it in a low spot or in an area where there's a lot of junk in the ground or whatever, you're going to be spending years trying to correct all of the negative effects of that piece of property. One of the things that I point out to customers when they do build a new structure, that the first year they will have more of an issue with moisture, simply because all of the ground moisture that is there has to be gotten rid of. Once that moisture has evaporated and you ventilated it, your structure will behave a lot more the way you want it to. So if you are putting it in a spot where there is a lot of ground moisture, you'll be dealing with that all of the time. High moisture in a greenhouse is not a positive concept. Another thing is, if your ideal location for your first greenhouse requires a $10,000 driveway to get there, you're probably going to want to start with something a little bit more temporary so that you can have some return first before investing in your $10,000 driveway. When you're thoroughly thinking through all of these things, it is going to prevent yourself from getting backed into a corner, and especially at the time of expansion. As a summary for this presentation, I'm just going to recap a few things that I consider important and that what I feel you should take away from this. Go back to the very beginning. What are you trying to accomplish? What are you dealing with? Be very methodical in listing your purposes and goals. Carefully research your size, shape, covering, and location option and requirements. Build your network of relationships. Prioritize, 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 and give yourself time. Make sure that you look at everything as a cost versus benefit, a cost versus return. If you're very diligent in doing all of these things, you're going to be prepared, and you can quite likely avoid situations like what these people experienced. Thank you for your attention, and happy greenhouse planting. Yes.
Could you speak to or refer me to where I might find out more about heat?
Heat? Heating, the question has to do with a reference to where to get heat. We used to sell heating equipment, and so like I'm fairly knowledgeable in sizing heating systems and stuff like that. But what I found in the past is, because I'm not a licensed technician, I'm legally not allowed to give specific advice. That having been said, my suggestion to people when considering a heating system is to buy from a local person. If you're buying from a local person, you're now in a position that if you have a problem, it's not going to be in the middle of an afternoon on a warm day. It's going to be at a time that's inconvenient. If you have a relationship with somebody, you can call them up in the middle of the night and say, I need you here now. So that's point one. Another thing to consider is when you're getting a heater for a greenhouse, make sure that you go with stainless steel heat exchanger and burners, because the humidity in a greenhouse that is inherent in a greenhouse will kill the aluminized heat exchangers. Yes, sir.
Can we expand a little bit more on orientation, north-south versus east-west?
Okay, like if you have,
Just chalk.
okay, let's say this is your greenhouse. And okay, so in my case, this is the sun is coming up from the east. The sun comes up and around like this. So it will create certain shadows, and again, depending on where you are, how high the sun is, the time of year, and when you're growing and stuff, you're going to get certain shadows. If you build the structure like this, you're going to get different types of shadows at different times of the day. So you have to look at what type of ends you have, like what will transmit light, and again, you just look at which way the greenhouse is sitting, which way the sun will shine, and it's actually not hard to determine just by putting something up and then watching how the sun will cause shadows for that. Just watch what it does to a particular tree in that area. Yes?
Plastics, especially in the sunlight, release a lot of rosins and hormone mimics. Has anybody done any studies of plant uptake of these in greenhouses?
I know that there have been studies that have done. We're getting into like a very technical, like almost like a chemistry situation that I don't know the specifics of. I do know that it depends, it always seems to depend on which viewpoint you're starting from. If you're out to prove that plastic is the worst thing since whatever, it's easily to have the numbers skewed to that effect. Vice versa, if plastic is the only covering, then all of a sudden, like, you have a different way of interpreting the numbers. And it's always been sort of comical to me how when times are really good, the comment you get is the only way you can grow is under glass. And yet when the times are tough, then all of a sudden everybody seems to be growing quite well under plastic. Yes?
Sorry, yeah, about the general shape of the greenhouse, the rectangular versus the cube or the square.
Yeah.
The square is more expensive because it requires longer span. But you were saying, I didn't catch the surface area. You were saying that the cube would have less surface area though, wouldn't it, than the rectangular form?
See, the structure that is 30 feet wide has
Huge.
a tall cover. Like, we have to make it taller so that it will shed the snow, and we're using heavier material, which means that the distance over the top compared to the floor space is a lot higher than when you take a smaller structure that can be quite low. If, like, one of the modifications that we do quite often is that we take, when a person needs, let's say they want to park a tractor trailer in a structure, well, they need something narrow and very tall. So then your surface area still becomes the same as if you're building something that is wider. It's just that in the bigger area, you're getting more return for that surface area than if you're squashing it together. Yes?
Can you comment on geodesic dome shapes for greenhouses?
It is an extremely efficient, it is extremely strong because of the way that it spreads out the load. One of the things that we have done a few of is what we call our igloo, which is like a round structure going to a dome. Even though it is extremely strong, it deflects the snow and the wind very well. It is a more complicated thing to build and to install. So again, coming back to that cost versus return, it looks interesting, it acts interesting, but you know, if you've got $2,000 to spend, you can get a lot more square footage if you go to a rectangular building. At the back?
Yes, what's your view on using like reclaimed lumber or posts, like from trees in building a greenhouse?
Okay,
Straight flex.
reclaimed anything might save you money now, and you have to look at it as, you know, again, a cost versus benefit. If you start with something sort of, we'll call it second grade, you're going to wind up in a situation where the structure is still going to be good, but you've got a problem with your foundation, which requires taking it apart and rebuilding it. Now, if you're in a situation where you say, I've got $2,000 to spend on this and not a nickel more, okay. Again, it comes down to making your wish list and prioritizing it. If it means going with little fancier posts and going with a smaller building that lasts a little bit longer, okay, you're going with a smaller building that gives you less return. So again, it becomes a cost versus benefit, cost versus return.
Let's say you were using logs to build ground, and you actually sink the logs into the ground, you use them as cross braces and do that. It's a fairly strong structure if you're using, you know, trees.
The only thing that you have to be cautious of in that scenario is the type of wood that you're using. Certain ones definitely last a lot longer than others. And see, that's something that comes up a lot in a lot of conversations with people that are certified organic. You're not going to use pressure treated wood. Then on the other hand, you're not going to go and use poplar either, because it's going to rot pretty quick. But then, you know, you can use cedar or cypress, which is extremely expensive. So it comes back to this cost versus benefit, cost versus return.
What's your take on greenhouse control and monitoring? Like what systems would you recommend or use, or like what would be optimal usage?
Obviously, the simplest method is going to be something that you've got electrical hookup to and you can run through a thermostat. That's something that will automatically come on when it needs to, go off. It can be sized according to what your requirement is. If, on the other hand, you go to roll-up sides, you can ventilate it just as efficiently for a lot less money, but you need to be there to open it, you need to be there to close it. So again, I hate to sound like a broken record, but it's cost versus benefit. If you're off doing your day job while your greenhouse is being established, you basically don't have any choice but to go to a motorized electrical system that can run by itself. Because if every plant has a threshold temperature, and when you cross that threshold temperature a little bit, you're going to stop the growth sometimes for 7 to 10 days. If it gets bad enough, you're going to just outright kill the plant. But you know, so that's something you have to be very cautious about. Yes.
With regards to positioning the greenhouse, would you say that of the two location points, that is north-south compass being the desirable one, or to the prevailing winds, would you say one is more important than the other?
Well, it comes, the number one requirement is going to be, you know, what does the crop that you're going to be growing require? If you're growing cut flowers, cut roses, whatever, like, it is critical that you have maximum light transmission. Like, one figure that is generally accepted is that 1% more light is 1% more crop. So when you're talking something that has a very high requirement, it's going to make a huge difference on your return. Back corner?
Is there a simple test or a rule of thumb that can tell you when you need to replace your plastic?
That is a question that I regularly get asked. Greenhouse plastic comes with a 4-year warranty. And then and after 4 years, the plastic is still very good. And people will say, do I need to change the plastic? I'm not going to put myself at risk by saying, oh, that plastic is fine, and something happens. I know for myself, in any of the plastic covered buildings that I have, I sort of give it the finger test in September, and I'll take the sunny side of the building, which is the one that's going to be deteriorated the most, and if you poke your finger at it, if with a relative ease you can poke your finger through, you need to be changing that plastic before winter. If it requires a fair bit of stress and you're just making a dimple in it, that plastic should be good to go. Like, I regularly get calls from people that they'll say, well, it was 10 years or 12 years ago that I got the structure, I need to have some new plastic. The plastic does last a long, long time. A lot of people are surprised with how it does stand up. Again, plastic as it gets older, it does get grungy and it fades, and your light transmission is a lot lower. One good thing that you should invest in is a light meter. Light is something that a light meter measures light a totally different way than what you and I see, because what the plant needs is light that is totally different from what you and I see. If you have the light meter, you know what you're getting in there. You can research what the light requirement is for the crop that you've got. You know when it's time to change. Yes?
I'd like to know your opinion, or are there any studies that tell you the difference between doing some sort of thermal blanket inside or outside, or versus heating it, or even submerging it more into the ground?
Sorry, can you repeat that?
I'd like to know if it's wise to invest in a thermal blanket system that goes inside or outside, or even submerging the greenhouse. You can go 5 feet below grade versus the cost to spend heating it as needed.
When you're building a greenhouse into the ground, yes, your heat loss is going to be reduced significantly, which means that your heating costs are going to be returned. It's also much easier for a building to get buried with snow, which means that you've got close to zero light transmission. The lower your light goes, the less production you're going to get. So again, it comes back to and why you have to research very carefully what you're proposing to do. Obviously, the hole in the ground doesn't come for free either. And again, so if you're going to get a reduced crop production, it might be short-sighted savings. One thing that I do suggest quite often to people, if they're worried about like protecting the building for frost that is penetrating on the sides, do not, absolutely do not excavate so that you can put styrofoam or some sort of insulation straight down. Because what happens is you're significantly disturbing the soil around your anchoring system so that it has got very little holding power. If you want to insulate around the base, what you're a lot better off to do is to put the styrofoam horizontally beside the building and then just backfill with a little bit of gravel so that it's out of the light. Styrofoam itself will deteriorate very quickly when it's exposed to the sunlight. What it also does, by keeping the cold away from it, you're also keeping the weeds away from your greenhouse a little ways. Yes?
Sorry, this is
Are you familiar with, there's a contractor out east who's developed the first soap bubble greenhouse?
Yeah.
You are. What's your opinion on that?
Okay, so the question has to do with the soap bubble greenhouses. We actually have done a few of those. The original concept, the gentleman put 2 layers of plastic basically on the same, and then pressurized it and put the bubbles in between. What we have done instead is build a structure that's a little bit stronger with a single layer of plastic and building another very light building on the inside that's simply there to carry the plastic. Then you pump the bubbles in between. The soap bubbles are extremely efficient for their R value. Generally, you're getting R1 per inch. You have the benefit as well of dividing along the ridge so that you can put soap bubbles on the one side, the north side, not on the south side where you're getting the light. It is extremely efficient in keeping the heat in. I've heard some amazing numbers as far as the low cost for heating. You are looking at a pretty expensive initial equipment cost to get a program like that started. Yes?
You were saying that, more or less, that the long and narrow will be lesser cost than the square one, but what about the longer surface or area you have to blow fans over? Would you not need stronger fans for that? More expensive fans?
Sorry, I missed, whoops. Oh, that was a good spot to spill. If you can repeat that, please.
You were saying how long and narrow is a lesser cost.
Yes.
For that, would you not need more fans to circulate the air?
No. No, because what the ventilation requirement has to do with the total volume of air that you want to move. A ventilation system, a proper ventilation system does 1 air change per minute. So when you have the lower building, you've got a smaller volume of air, so you're not necessarily getting into a bigger ventilation system. Now, if you take that to an extreme, let's say a 10-foot wide that's 300 feet long, or like just for throwing something ridiculous out, the air coming in has to travel all that distance, so it does pick up heat as it's going. There is a point that is not efficient anymore. So again, what I made reference to was that, like I said, you know, in certain things I'm doing it sort of an overly simplistic just to illustrate a point, but it does need to be considering the whole picture.